So let's take a look at an example. We have a transformation T from R3 to R4. It's the linear transformation induced by this matrix. We want to know if T has an inverse, if T is an invertible transformation. So to do this, we need to know if T of x, which equals ax, if this function is 1-to-1, if it is onto. So what we want to know is there some vector y in the codomain so that this equation, this linear equation, would have infinitely many solutions? If so, then the transformation is not 1-to-1. If there's any situation where you will have infinitely many solutions, then it's not 1-to-1. For onto, we want to check, hey, is there any y here that's going to make this system of linear equations have no solutions? If so, if this matrix equation ever has no solution, if for any y I could put here, then the linear transformation is not onto. Okay, so what I'm going to do is I'm going to focus on matrix A, and I'm going to find the reduced row echelon form of matrix A. So I get 3, 4, 4 is the first row, 0, -1, -5 is the second row, -3, 5, 4 is the third row, and -3, -3, 1 as the fourth row. And I want to find the reduced row echelon form of A. And there we go. Okay, notice I haven't augmented it with anything. Okay, all I'm looking at right now is just the reduced row echelon form of A. And now what we're going to do is we're going to imagine what happens if we do augment it with something. Okay. Now, we want to check if we are 1-to-1, if we're onto. So let's do 1-to-1 first. Is this 1-to-1? So 1-to-1 means that we only have, whenever this linear equation has a solution, there's only one solution, not infinitely many. Okay, so looking at this, will we ever have infinitely many solutions? Well, no. Every column in the coefficient matrix has a leading entry in it, has a leading 1. Because every column has a leading 1, we will not have any free variables, which means if we have a solution, it's going to be a unique solution, not infinitely many solutions. So is the function 1-to-1? Yes, it is. Transformation is 1-to-1 transformation. Okay, now let's check, is it onto? Okay, now it's going to be onto if every y from the codomain can be plugged in here and we have a solution. Okay, for every y from R4, can we plug it in here and have a solution to this equation? That would be onto. We need to be able to map onto every value from the codomain. Okay, but if we look here, we have exactly what we were worried about in this last row. A lot of zeros, and then we could choose this D to be something that's not a 0. If that's not a 0, then that means that this last row would correspond to an equation with no solution. So there will be situations where this equation will have no solution, which means it is not an onto transformation. There are values of y that I could put here that will give me some non-zero value here. And so it will not be an onto transformation. Now, because it's 1-to-1 but not onto, it doesn't meet both criteria. The transformation does not have an inverse. It would need to meet both criteria to be an invertible transformation.